This question is about how you can take something like an exponential, a nonlinear graph that would look like this, and plot slightly different quantities. Instead of plotting p against t, we're going to plot log p against t, and we're going to get, instead of a nonlinear curve, we're actually going to get a straight line, something like this. How would we get that? And also, what do the gradient and the y-intercept represent? Well, what we can do is start with this equation here and take log of both sides. Log to base 10, let's go with that. So I'm just going to write log because that means base 10. So I'll get log p equals log a plus log b to the t. I can bring that t down using my third rule of logs, and then I can write it as log b times t plus log a. And I've written it like this because now I see here is my y, here is my m, this is going to be my x, and this is going to be my c. So if I plot log p against t, I will get a straight line where the gradient is log b, and the y-intercept, or the, I don't know, the log p-intercept, or whatever you want to call it, is going to be log a. And that will allow us to work out a and b. Because all I need to do is to get b, let me write it here, so b is then going to be 10 to the power of 0.0054. So we can work that out. I'll leave you to put that on your calculator. So we get 1.01251, which I'll then round, because it says to 3 decimal places, to 1.013. And then very similar for A, it's going to be 10 to the power of 0.81, which ends up being 6.45654, which gives 6.457. Wait, 6, that was meant to be a 5, 657. And hence our model prediction is actually going to be P equals 6.457 multiplied by 1.013 to the power of t. Okay, that's not what we're asked for, but I think it's quite good to write that down. We're then asked in the context of the model to interpret the value of the constant a, and I think it really helps to write this down because here is a. So when we substitute t equals 0 in, actually we'll get p equals a. It's like just doing exponentials. We have 2 to the x. Well, it's sort of 1 times 2 to the x. It always goes through 1 here. If you had 3 times 2 to the x, it would go through 3. It's what happens when x is 0. So A is going to be the initial population, or I should say the population in 2004, as predicted by the model. And then B is this bit here. I've always struggled more to be able to write this one down. I've gone with things like it's the multiplier, and I've said like the percentage increase would be 1.3%. You tend to get away with that. One time I started using this, it said it was the ratio, the population from one year to the next. I do like the mark scheme in this paper though, so I'm going to go with it. I think I'm going to use it from now on. It's the scale factor of increase in the population. You get away with quite a lot of things here. Just don't say it is just the increase, okay? Because it's like a multiplier, or as we're using here, scale factor. Then use the model to estimate the world human population in 2030. So that is going to be when t is 26. Therefore, prediction is p equals 6.4. Now, I always think we should use the full value. It's not really going to matter here, but we shouldn't use rounded values at any point. Then 1 point, and this can make a big difference sometimes, especially when you're doing an exponential function, 1.01251 to the 26. And this ends up giving 8.9203. So I'm just going to round that to 8.9 billion. do need to bring that billion back in because we were told before that the population was in billion. As long as your answer rounds to 9, then you're okay. I've gone with that. And then comment on the reliability. Well, it's not very reliable because we're looking, we had this straight line with these presumably some data values up to what year was it? Like the third year, and we're trying to make a prediction, like well beyond at 26. We cannot assume that the trend is going to carry on as a straight line, and hence that the graph will carry on as an exponential. So we've extrapolated. We have extrapolated. And that does mean like that you're going outside of the data range. So do you know what? When I wrote it, I wrote we extrapolated outside the data range, but that is what extrapolated means. So the result is unreliable. As long as you say something about it being outside the data range, then you'll be okay. That's it. Well done.